What is already known about the study subject? Things we already know about the study subject are that the hanging weight will supply the force on the cart, which will make the cart move. Another thing we know is that the net force depends on the hanging mass, and we will be changing each time, so the net force will be different each time we use a different mass. Also, we know the mass of the cart will not change throughout the experiment since we won't make any changes to it. To add on, the surface on which the cart will be rolling doesn't have a lot of friction, which in turn won't have a big impact on the results of the experiment. What do we hope this experiment will tell us about the study subject? We hope through this experiment we will learn how changing the weight of the hanging mass will affect the acceleration of the cart. Our claim is that if we increase the weight of the hanging mass, then the cart will accelerate faster each time we do so because there will be a greater force.
The independent variable of the system is the net force that it experiences. This is changed when you change the masses that are on the cart as well as on the string. The change is the difference between the mass on the string and the mass on the cart in newtons. The dependent variable of the system is the acceleration produced by the moving cart. The acceleration is varied by the amount of weight attached to the string hanging off the table. The heavier the weight, the higher the acceleration would be. We found the acceleration by first using a motion sensor to create a velocity versus time graph of the cart as it moved. From this graph, we are able to find the slope of the curve of the graph to find the acceleration of the cart. To control this experiment as much as possible, we made sure the mass of the cart always stayed the same throughout this portion of the lab. Another way we were able to control this experiment was by trying to put the cart in almost the exact same place every time, so that it would not turn or deviate from a straight path. For our procedure, we first placed the cart on a level surface. Second, we tied a string to the cart and attached a 5-gram weight to the string. Third, we started the sensor and made sure it is as still as possible as well as pointing at the cart. Fourth, we dropped the weight while it is attached to the string off an edge. Fifth, we recorded the movement of the cart provided by the sensor. Sixth, we found the acceleration of the cart by finding the slope of the curve of the graph. Seventh, we repeated steps 2 through 6 using various masses that are hung off the table.
Alright, three,
I've done that before.
1, go.
The data shows that the amount of kilograms added to the cart can change the acceleration drastically. Some problems we encountered during the procedure is that the mass keeps falling off the string. We resolved this problem by placing the mass back on the string, and ideas that I came up with for the study subject is that we could measure the frictional force on the cart as it moves along the track.